Hello people, welcome to Gurukula. I'm Jai. So today in this video we are going to see about the routing algorithms and then the routing protocols. So without any further delay, let's get into the topic. So whereas in our previous video we might have spoken about what are all the various concepts that is related to routing. So we might have discussed three principles that is coming in adherence to the routing concepts. So one is the delivering, the second one is the forwarding, and third one is the routing itself. So by the end of discussion we just came to know that when we wanted to create a routing table which is to be implemented on a dynamically varying network, we definitely need few routing algorithms and then the routing protocols. So this video is going to be a continuation video from the previous one. If you have not yet watched the previous video, I will leave you the link in the I button and as well as in the description section. So please do check out the previous video and then you can continue with this. So with this note, let me continue with what exactly the protocol and then what exactly the algorithms are. So before exactly understanding what routing protocol and routing algorithm says, we should have a clear understanding on what exactly algorithm is and what exactly the protocol is. So in order to make it very clear, let me put out this particular statement. So this statement tells us what exactly the protocol is. So what does the statement says? A protocol is a set of rules that determines how the system functions. So keep in mind that protocol is always going to tell you how the system has to function. So in order to keep it in mind, we can also call this as a protocol is something which has to be respected. Okay, so on the other hand we have algorithm. So let me put up another statement that will tell you what exactly algorithm is. So this statement says that the algorithm tells that the system what to do. So the algorithm are the various steps which a system will execute. So that is what actually algorithm is, an exact thing which says the system what to do in order to achieve a particular task. So algorithm is something which has to be applied and it should be followed. So in bird's eye view we can say that algorithm is something which has to be applied and which has to be followed for sure, and protocol is something which has to be respected, right? And then in other words I can also tell you that algorithm is something that tells you what to do and then protocol is something that will tell you how to do. So even though for few viewers it might not be very clear, so that in our usual way we will take up an example and then we will try to understand what exactly protocol and then the algorithm is. So in order to make our example more spicier, what I'm going to take is I'm going to take an cooking recipe. So let us try to cook something. So I am trying to cook something and then the algorithm goes like this. This is what the algorithm says. So in my recipe, the first step which I wanted to perform is I will have to chop the onion. So that is the very first step which I have to perform. And once I am done with chopping the onion, the second step which I have to follow is I will have to heat up the olive oil in the pan. And then once the oil got heated up, then what I will have to do, the third step is I need to put the onion in the pan. I need to add some salt and I will have to stir until the onion is translucent. So this is how the recipe goes. Alright, so this exact step-by-step process is what we call it as algorithm. So can you observe that algorithm is telling me what to do, correct? First I need to chop the onion, then I need to heat up the pan and then I will have to heat up the olive oil and then I need to put the onions and then I have to saute the onions until it becomes translucent. So doesn't it tell me that what I have to do in order to come out with a very good recipe? So that is what algorithm is. And then if this is algorithm, then what exactly protocol means? So protocol is something which has to be respected. So that will tell you, or these are all the set of instructions you can respect or which you can follow in order to come out with a very good recipe. So the protocol says that you will have to use knife to cut the onion. Onion can be cutted out by using many several ways, and you can use any other kitchen gadgets to cut the onion, but using a knife will give you freedom, and then that will give you a nice shape. So that is what the protocol says. And then the flame heats. You can heat up the pan by using any method, but if you use flame it will be quicker, the time will be saved. And then olive oil is delicious, and of course you can use any oil for your recipe, but olive oil will give you good taste for your recipe. And then frying pans are good for sauteing onions. You can put onions on any kind of pan, but frying pans are more suitable pans to saute the onions. So you will have to wash your hands before handling your food. You can prepare your food even without washing your hands, but for the point of hygiene, it is better to wash your hands always in order to keep your food more hygiene. So your protocol is something which you will have to respect in order to get the optimum output. So that is what we call it as the protocol is. So now I think all the viewers might have got what exactly algorithm is and what exactly the protocol is. So algorithm is something that is telling you what to do, a step-by-step procedure which you need to follow in order to achieve a particular task. And protocol is something that will tell you how to do each and everything in order to get an optimum result in that particular task, whatever you are performing. The same thing is going to be applied. So when I have an algorithm, then definitely I will have an associated protocol with it, right? So that is what the thing which I am trying to drive from this particular slide. So I think, or I hope that every one of you might have understood what exactly protocol and then the algorithm is. So now we will march forward and then we will try to understand what exactly the routing protocols are. Why do we need routing protocols? Because routing is the most important task in the network to forward packets from source to destination. So as we discussed in the previous video will tell you how exactly the packet is being routed from one point to another point, or in other words from source to destination. So in order to transfer a packet from source to destination, all the intermediate nodes, we call it as routers, who is the responsible for routing the packet to the correct destination, requires a routing table. So in that routing table you will have the information of the neighboring nodes, without which transferring a packet is not possible. So how a router will acquire information about the network or the neighboring nodes, at least at the initial stage. At the initial stage, each and every router must get an information about the neighboring router, and later on each and every router must know the complete picture of the entire network. So how is it being acquired? How the router is getting a complete information about the entire network? So there comes the routing protocol that will tell you how to acquire the information about the network. So before directly jumping into understanding routing protocols, we will have to make a little bit of changes in how do we look into the network. So the perspective of looking into the network has to be changed a little bit in order to understand the routing protocol and then the routing algorithm. So we will have to or in other words, I can say that the routing process can be well understood if you represent the network as a graph kind of thing. So instead of looking into routers, switches, servers, all these kinds of things, what you can do is you can put everything as a node. So each node on the network may be represent any host. So any host on the network or any switch on the network or any device that is connected on the network can be viewed as a node. So once it is viewed as node, that this is how the image will look like. And then so each node will have to be connected to each other by using a link, and each and every link will have a metric as depicted over here in the picture. So when you look at this particular figure, you can see that there is a node called A. So when I have a node, all the circles in this particular figure represents a node. This is what we call it as a node, and then each and every node is connected by a line, and this line is what we call it as a link, which means this node can be of anything. It can be a switch, or it can be a router, or it can be a host, or it can be any device that is connected on an internet. And then you have another line which is connecting two different nodes, and these lines is what we call it as a link. And this link is nothing but it can be anything. It can be an Ethernet cable that is connecting, or it can be an Wi-Fi link that is connecting the nodes, or it can be any connection media that is actually establishing the connection between one node and then the another node. It can be viewed as a medium. It can be wired, it can be wireless. If it is wired, it can be Ethernet, or it can be coaxial, or it can be fiber, or whatever it is. So that is what we call it as a link. And then you can see numbers over here. So all these numbers that is mentioned in every link represents the metric, or in other words we call it as cost. So generally we will take this cost as the number of hops. So what do you mean by the number of hops? Let's take for an example, A is the node which is connected over here, and B is the node connected over here. And considering the distance between the A and B, this might be connected by using several number of intermediate devices. And also remember, in network there might be multiple number of routes to reach a particular network. So here this is what the first route, and this is what the second route. So if I have taken the first route, then I will have to go 1, 2 number of hops. This is my first hop, this is my second hop. So what I will do is I will assign the cost as 2 if I take this particular network. So 1 and 1 over here. And then these are all the intermediate networks. If I have to take the second route, then obviously 1, 2, 3 and 4. So there are 4 number of hops which I have to perform. So this 1 and 4 is what we call it as something called it as metric or the cost. So we can generally take the number of hops as a cost, or you can also take the bandwidth, or you can take the delay. The cost can be anything, but in most general situations we will be using number of hops as a metric over here. So this is what the representation of a network what we use in our subsequent classes in order to understand the routing protocols and then the routing algorithms. So next, coming to the routing protocol classifications. Routing protocols are classified based on their characteristics. So in order to look into the characteristics, if I have to classify the routing protocols based on the purpose, then I can classify them as interior gateway protocol or exterior gateway protocol. If I have to classify based on their operation, their mode of working, then I can classify them as 3 different ways. One is distance vector protocol, another one is link state protocol or path vector protocol. If I have to classify based on the behavior, then I can obviously classify them as class full addressing or class less addressing protocols. So these are all the various classifications of routing protocol, and we will try to put all of these types in one picture, and then we will try to get the bird's eye view of classification of routing protocol. So this is how the routing protocols are classified. So in our previous videos, you might have remembered that I might have stated about the static routing protocols, but the static routing protocols we will not be used in a wider sense, because that is not a suitable routing protocol for dynamically varying environment, and especially for the bigger networks kind of internet, then the static routing protocols will have no use in that. So definitely we will be using the dynamic routing protocols which have an ability to update itself or automatically whenever there is a change happening on a network. So these are all the various types of routing protocols. Starting from the dynamic routing protocol, it is initially classified into interior gateway protocol and then the exterior gateway protocol. And whereas the interior gateway protocols are further classified into distance vector and then the link state. And on the other hand, the exterior gateways are further classified into path vector routing. And each and every algorithm, what I do is I will consider this violet color band represents the algorithm. So these are all the algorithms, and in other words we can call it as routing algorithms, and whatever it is mentioned over below this algorithm stage we call it as the protocols. So this is going to tell you, algorithm is going to tell you what to do, and then the protocol is going to tell you how to do. So that is what we are going to see in the subsequent videos in this particular lecture video series. Now we will try to understand what exactly this interior gateway protocol and what exactly the exterior gateway protocols are. So in order to understand what interior protocol and then what exterior gateway protocol is, we need to understand about a concept we call it as autonomous system. So what do you mean by autonomous system? Autonomous system, for an example concern, what I can consider is, so I can take an internet service provider. So let me consider this is ISP1. So this particular internet service provider, can be any network or any domain. Let me take it as Jio or Airtel or BSNL or whatever it is. So if he is an internet service provider, Jio, they will have their own infrastructure, their own customers, their own billing facilities and their own tariff for using their particular network. And similarly, we don't have only one internet service provider to connect the entire world. We will have different internet service providers and multiple internet service providers. So as of example, I will consider there are two internet service providers for our example, right? So each and every internet service provider will be termed as a different autonomous system. So Jio is a separate autonomous system where they can autonomously operate or they can autonomously change the infrastructure over there. So each and every internet service provider, we call them as the autonomous system. So whenever a packet is being exchanged within this particular internet service provider, we call them as intra-domain routing. So we call them as intra-domain routing. And similarly, whenever the packet is being exchanged or the packet is transferred only within this particular network, we again call this as intra-domain routing. And this intra-domain routing is also called as interior gateway protocols or algorithms. Alright, so interior gateway protocols or intra-domain routing or intra-domain protocols are one and the same, which will allow the packets to get exchanged only within the autonomous systems. So but this is not the criteria which we need. In order to satisfy the internet criteria, each and every node on a network should be able to connect to multiple nodes on the another network as well. So in order to do that, we will have to exchange packets from one node to another node. So how do we do that? So if my packets is getting exchanged from one ISP to another ISP, or if I could able to exchange my packets from one autonomous system to another autonomous system, then that type of routing is what we call it as inter-domain routing. So this is what we call it as inter-domain routing. So inter-domain routing is nothing but where the packets are being exchanged or the packets are being routed within two autonomous systems. So if the routing is happening only within the autonomous system, then we call it as intra-domain routing or interior gateway protocol. And if the routing is happening among the autonomous systems, between two autonomous systems, then that is what we call it as inter-domain routing, or in other words, it is also called as exterior gateway protocol. So exterior gateway protocols. So obviously this particular thing we have, so if we discuss interior gateway protocol, interior gateway mechanisms will have different algorithms, and then if I have an algorithm, then obviously I will have different protocols associated with it. So when we talk about the algorithms that is corresponding to interior gateway protocols, we have distance vector algorithm. So distance vector algorithm, and then we have link state algorithm. So these two algorithms are corresponding to interior gateway protocol, and then if we have an algorithm, there must be an associated protocol with it. So here in our lecture video series is concerned, we are going to discuss about the distance vector algorithm, and the associated protocol is routing information protocol, which is abbreviated as RIP. So RIP stands for routing information protocol. And for the link state algorithm, we will be discussing another type of protocol, which is what we call it as OSPF, open shortest path first. So OSPF is abbreviated as open shortest path first, and that is the protocol which is associated with the link state algorithm. And when coming to exterior gateway protocols, so we have to discuss one algorithm, so that is what we call it as path vector algorithm. So path vector algorithm is what we are going to discuss, and this path vector algorithm really has a capability to route the packets from one autonomous system to another autonomous system. So that is what we call it as path vector algorithm. So if I have an algorithm, then definitely there must be a protocol associated with it, and protocol that we are going to discuss in association with path vector algorithm is border gateway protocol. We call it as BGP. So BGP is abbreviated as border gateway protocol. So I think this particular figure and whatever we have written over here will give you an bird's eye view of how exactly the routing protocols and algorithms are being classified. Now when we get back to our previous slide, I think that will give you a better understanding. So now you can understand this very clearly, correct? So we have dynamic routing protocols. Now we know what interior gateway protocols are. Interior gateway protocols are nothing but we can able to route the packets only within the autonomous system. I will call it as AS. And then exterior gateway protocol, we can able to route the packets among the around different autonomous systems. So we have autonomous system 1, we have autonomous system 2, and if I could able to transfer the packets or route the packets from one autonomous system to another autonomous system, and that is what we call it as exterior gateway protocols. So if I need to exchange the packets, both requires different mechanisms. So I have different algorithms and then different protocols associated with it, and the algorithm associated with interior gateway protocols are distance vector and link state. And for distance vector, we are going to discuss about RIP, and for link state algorithm, we are going to discuss about OSPF, and for the path vector routing, we are going to discuss the border gateway protocol. So in our next subsequent videos, we are going to discuss about each and every algorithm and the protocols corresponding to it. So I think this makes sense with you, and I am completing the video over here. We have came to an end of this particular video, and I am going to meet you all in the next video. Until then, it's bye from Jai, and then happy learning.